Welcome back, everybody, to part 2 of Vista. We're welcoming back the Vista team. This time they're going to be sharing time split testing for pricing optimization at scale and a method for automated sample ratio mismatch detection and analysis. This time we're going to be hearing from Kevin and Josh, who are going to be talking with us on those two methods. Kevin is the experimentation product manager. He helps experimenters increase the pace of experimentation. He's also the author of the Experimental Mind newsletter. If you're not familiar with it, check it out. I've got the link there for you. And Josh is the lead data product analyst. His focus is improving consistency, accuracy, and automation of price change measurement as part of Vista's journey to scale from implementing tens to thousands of price changes per year. So I'm going to pass the screen share over to you all. And Josh, I think you're taking the lead first, yes?
Yes, I am.
All right.
Thank you very much for the introduction.
You betcha.
So I can control the screen then, is that how it works? Or?
Yes. Bottom center of the screen where it says share screen.
Okay, I see. Here we go then. Let me get this into presentation mode. Okay, so thank you very much for inviting me to talk today. This is a topic that I am very passionate about, so I'm glad that there's an audience for it. So I will be talking about time split testing. Many of you may have heard this under another name, such as switch.
Still not in presentation mode.
Am I still not in presentation mode? Okay. Let's see if I can do it this way.
There you go.
Then
Presenter.
Here we go. Perfect.
There you go.
Thank you. So many of you may have heard about time split testing as switchback testing or crossover testing, and you may have heard about it in being used in slightly different domains. So typically, it is a form of experimentation used for form of controlled experimentation used for when there are network effects which would invalidate any interaction assumptions that you would normally need to have for A/B type testing. However, for reasons that I will explain, we have found another use case for time split testing, and that is with list price changes. So let's move on to the first slide then. So just to recap, for those who know and for those who don't, here's a definition of what time split testing is. So time split testing is another form of controlled experimentation. Like A/B testing is a form of controlled experimentation. But the major difference between time split testing and A/B testing is instead of randomizing visitors or your population as you would do with an A/B test, you randomize units of time throughout your experimentation between your control and your test treatment. Now, why are we using this for measuring the impact of list prices? So we have tried A/B testing before, and there were many challenges with A/B testing. So from my experience, A/B testing in many circumstances is the gold standard for measuring impact. However, it is also best suited to certain types of experiments. For example, when you're testing one particular page on your website, or you're testing one particular channel, such as email. But something like list prices persists throughout many different parts of your website, throughout many different channels. So whether it's on the site itself, or through paid search, or through email, and having one A/B testing experience that can control that and ensure consistency is very difficult. I mean, if you think about it, if someone is a regular customer, they're usually logged in, we can track them being logged in. We can show them one experience quite easily, but if they pick up their phone and they're not logged in and they see the same prices on the website, then they're going to see for the same product different prices, and that is a type of inconsistent experience at any one given moment in time, which we are not very comfortable with for our customers. The alternative way which you can measure this price experiment is through regular pre-post. So you make the change and you try and measure what the performance is against what you expect the performance to have been, either through a difference analysis or against a forecast of some sort. But the main downside is that this is not controlled experimentation, and it is not consistently reliable enough. And when you're measuring price changes are quite a powerful lever to bring about short-term change, financial change. And if you don't have a reliable way to measure your price changes, you don't know if you're heading in the right direction or not towards your performance goals. So just to recap, most people are familiar with A/B testing. Through one form or another, you would typically randomize your customers as they visit maybe a page of your website into either your control experience or your test experience. With time split testing, in the case of how we're using it currently for list prices, we're randomizing the days throughout the experiment into either control days or test days. So throughout the control days, people receive the regular pre-existing prices for a particular product or range of products, and on the test days, they'll see the new prices for those particular products. Now, I think one thing to clarify is what is a time unit. So I just mentioned here that we use time units of 1 day, but there's no reason why a time unit can be of any duration. So you might see examples where time units are 20 minutes long, 1 hour long, or anywhere in between. Now, the best type of time unit is the one that is most suited to your experiment if you are to be using time split testing. And you have to consider many factors as to which is the right time unit for you. So for consistency for our customers, there can be issues if you are changing prices every 10 minutes. So we don't want to have that type of irregular experience, but we find if you make them too long, maybe you're using time units of 1 week, then the power of your experiment significantly diminishes. Other reasons why you wouldn't necessarily want to use small time units is although the power does increase, you have diminishing returns on power as time units become smaller. So you might have a time unit from an hour to half an hour, but the power of your experiment doesn't double. It might increase by 25% or 50% or something. So, but the downsides might increase more linearly. So you have to be slightly conscious of that. Other things to consider is the smaller your time units you have, the more potential there is for interference, if any. Now, interference obviously would depend on what you're testing for. But in the case of list prices, you don't necessarily want the price to change between the moment someone finished the design, they saw one price, they get to their basket, and the price changed again. That wouldn't be a very consistent experience for our customers. So we have to find the best balance between size in that sense. And the final thing is the tooling that you use. So we have automated tooling to help us deploy our price changes. But if there is a potential differentiation between maybe 5 minutes between when it says it's going to deploy and when it's actually going to deploy, then over a period of a day, that's fairly insignificant. But if you had time units of 20 minutes, then that would be 25% of that particular time period could be taken up by the fact that there's a delay in the deployment of the press release. So that's another thing to consider, at least in the case for list prices. Now, how does this work at Vista? Or Vista, I should say. I mentioned that people may have heard about time split experimentation before, so this is certainly not new. But the approach that we took from the very outset, before we even decided to trial it, is that time split experimentation should be self-service, and it should be as automated as possible. So we really try to follow two principles. One is that service it should be complete self-service, so pricing specialists can set up a pricing experiment on their own, and then the tooling will take care of the scheduling and so on. This is really to prevent any errors in execution. Imagine handling 25 or 50 price changes over a relatively short period of time. There's a high opportunity for error. So that's something that was essential from the very start. And also, we wanted as much of the analysis to be automated as possible. In the past, when we did maybe A/B testing, there's always a dependency on the number of analysts available to study the results of the experiment. So if we're trying to build something that's scalable, then you can't have a bottleneck in the experimentation process like that. Now, that's not to say that there isn't any room for analysts at all. As I'll talk about now, this time split experimentation has been a development of time split experimentation has been actually in collaboration with our experimentation hub. So this is where we advocate for best practices and provide advice on experimentation techniques and so on. So we encourage pricing specialists that are running experiments to collaborate with our experimentation ambassador to help set up the best test possible and to help the analysis of results, particularly when it is not so clear cut. But at the very least, the analysis isn't a bottleneck in the process. Also, just to point out a collaboration with this, as I mentioned, the prices are deployed by our pricing manager tool. This is being developed for us by Cypress Technology. Cypress is our parent company, so they have many of our technology scores sit with Cypress, and it's been a strong collaboration with them. I think maybe people can testify here. The deployment of any new experimentation technology relies on working with technology squads and so on to make sure that happens. And the final part of the triangle, we don't have a nice logo for our list price data product team, so I put we have our data and analytics logo here. So we're part of the data and analytics organization, and we focus on building data products which benefit the organization or our customers. So this has been part of the list price data product team as well to help develop this. So how does it work? With just a few clicks, the pricing specialist can upload a new set of prices with the pricing manager tool. They can set a date for the experiment to start, how long it should last for, and they can click deploy. So it works hopefully very similarly to how any other experimentation would work. There's although you're operating with along the time dimension rather than the audience dimension, then many of the principles of testing remain the same. You want to have a good hypothesis before you start your test. You want to know how long your test should run for based on the size of the change you're making and your minimal detectable effects according to the products that you're testing for and so on. So a lot of this should be very familiar to any any experimentation analyst. One further thing that we do take into account, though, is because we are working with time units of 1 day, we don't have a lot of granularity in our time units as we would like. So one thing we like to ensure is that due to our strong weekly business cycles, we want to have a balance of different types of weekday, i.e. Monday, Tuesday, between this with control partition and your test partition, so that we are accounting for, before the experiment even starts, you're accounting for any differences that are down to the major driver of performance in the business. Other than that, the tooling takes care of the randomization and the scheduling. So you remove 1 degree of freedom in your randomization, but the trade-off is that in this case, you get much better, you're accounting for something else that could interfere with results. Now, if you were measuring something else that didn't have strong association with day of a week, or if you had very fine time units, then stratified sampling of randomization probably wouldn't be necessary. So this would really depend on what you're testing or the metrics that you're using. So if you're using conversion rate, maybe it wouldn't be as necessary as if you're measuring purely item uplift or something like that. And just before I wrap up, I thought it'd be nice to talk about some of the next steps that we're looking to make. So at the moment, we really only have one flavor of time split experiment. You can vary the length of the experiment, but other than that, time units are always 1 day, and there's no opportunity to change that. So maybe some products you would get away with actually having slightly smaller time units, which would increase the power of your experiment, as I mentioned further before. And maybe for others you don't. So maybe this is something that we would like to give more control over to the price experiment specialists and experimentation ambassador, for them to be able to determine with some guidelines and framework that we could put in place to make sure that they're not going too small. So that for some products you can get more power where it's appropriate. The other thing that would really benefit the time split experiments is using region as another dimension. So in many cases, when we change prices, we are changing prices for one market at a time. However, if you are running a multi-market experiment, such as in the EU, you might be changing prices for a product in France, Germany, and the UK. You can randomize within the markets don't necessarily have to follow the same schedule as one another. If you allow the randomization process to set a different schedule for different markets, then you are creating more units within your experiments, and therefore you can increase power that way. So this is one area which we would love to explore. The next thing is, at the moment, it's like regimented. You only have your control and your test, one test variation. Maybe in the future, if there is enough power, potentially to test maybe 2 variations or even 3 variations, we'd like to open that door up as well. But obviously that will depend on the products and many other factors, because in some cases it's not going to be, we don't want to be running tests for 6 months either. So we have to obviously find the right balance there. And finally, I think the thing that I'm looking forward to most is finding a way in which we can create a framework that other parts of the organization can use, rather than having to go through the same steps that we've had to do, because this has been a hell of a learning experience, which has been both fascinating but taken some time as to how to best go about implementing time split tests. If we can create a framework which other parts of the organization can use, including code which they can use to help analyze their experiments, then we can give them a power boost in terms of how fast they can ramp up as well. So I'm looking forward to hopefully helping out the parts of the organization in the future with that. So that brings me to an end. Is this the right time for questions or?
I think so. Before we switch topics, we have a couple of questions that were put in the TLC calls channel that I'd like to, if we can. So the first was, I guess, power increases with diminishing time unit because it increases the frequency of price change, and it's like collecting more samples within the same test.
Exactly. Yeah. Exactly. Yeah. So you can also think about it where if, for example, we had we're working with time units in 1 day. If you were to get a really if you were quite unlucky, we might have 4 or 5 sale days in a throughout the duration of the experiment. And if we're really unlucky, they might all land into one partition. So let's say your test variable, and which can then conflate your results. And if you have smaller partitions, then the chances of all your sale days or your public holidays happening in the same partition decreases significantly. So that's why it can be better to have smaller time units.
Excellent. Let's see. Matt Gershoff asks, as the time slices are the unit of the experiment, for the variance, do you need to adjust the effective sample size to account for the clusters, or do you just use the number of slices as the sample size?
Can you repeat that, please? Sorry.
As the slices are the unit of the experiment,
Yeah.
for the variance, do you need to adjust the effective sample size to account for the clusters? Or do you just use the number of slices as the sample size?
So one thing that's, maybe take a slight detour first. One thing that's different is that you can't necessarily stop after you reach so many visitors. Unlike with an A/B test, you might have to work out what is the number of visitors you need before you your experimentation ends. With time split testing, you are, and this is one thing that is like a mind switch was not for, instead of thinking what is the minimum detectable effect you want, and then how many visitors it takes you to get that minimum detectable effect, we have to think in terms of, okay, for this length of time for experiment, what is the minimum detectable effect? So the time almost comes first, and then you work out the minimum detectable effect for different amounts of time. So we calculate the variance in the experiment by doing lots of randomized sampling of previous historic data, and the more units you have, obviously the variance will tend to go down, and vice versa. I don't know if that really answers the question well. I'm sorry. Maybe if you want to tag on another question, I can try and help answer that a bit.
I see he's typing. We'll come back to it.
Okay.
He says, don't sweat it. Is time better than clustering on geography? Is geo going to be less acceptable to do pricing from a perceived fairness? By geography, I mean, like postal code rather than country or county.
So obviously, if you were able to test in more geographies, then you would also increase the power. But at least in Vista, and this may be very different for different organizations, we ensure that prices are consistent across the market. So if you are in New York, you will get the same prices as you would do in Texas. So therefore, our region units defined by, we have an upper limit based on the number of markets that we operate. Now, if you're testing something that's far more localized and where people don't have the expectation that there should be consistency, then yes, you could test on any geographical unit that's appropriate to you, and that would give you more power.
Okay. And the last one, and then we will switch topics here. Where did it go? You removed it. Way to go, Matt. Never mind. Last question got removed.
Safe.
Right as I was about to read it. You're not clogging the flow. They're interesting questions, Matt. All right. we can switch. You're up, Kevin. Thanks, Josh.
Thank you.
Really great.
Thanks, everyone. Josh, if you could stop sharing, I can take over. Thank you. Is this looking good for everyone?
Yep, looks great.
Great. So, up for the next topic. My name is Kevin Anderson, and I will be presenting how we automated sample ratio mismatch detection and also the analysis part. Now, this is a short presentation, but we've also wrote a short paper on this. And in this, well, the next 15 minutes, I will go through this. What is SRM actually? I hope everyone knows what it is, but if you do not, then fear not, I will explain it. But most importantly, why we should care about it. Some downsides of current solutions, how to tackle this, how we at Vista automated the detection, some learnings, and some ideas on what we can do next. And of course, we'll have plenty of time for questions. Now, I have the privilege to share this with you, but this is joint work by Lucas Vermeer, Mauricio Acebal. Both are in the call, and they can answer all the difficult questions, hopefully. And of course, myself. So we all work in the experimentation hub at Vista, and it's our role or job to enable everyone within Vista to experiment on a large scale, but also that the experiments are trustworthy. And I think that is the topic of today, or at least SRM is a very important component in that. So let me start with what is sample ratio mismatch and why we should care. Now, in this example, I will explain what SRM is. In this case, you'll see a very simple example of what a expected and a observed ratio, sample ratio actually looks like. So in this case, we expect 50-50. We have set up our experiments in a way that we expect 50-50 split, but in actuality, we observe a slight difference. And you would say, well, what's the issue here? Well, there is an issue. If we go further, actually, we would expect here what we observe. This is another example where we observe something completely different, right? So in this case, again, we would expect 50-50, but in actuality, we observe 60-40. Now, sample ratio mismatch is just simply that the sample ratio that what we expect is not what we observe. And with a simple chi-square test, we can determine how surprising that observed split actually is. And there the things that we built come into play. But first of all, why should we care? Now, there are actually 3 reasons why we should care about SRM. First of all, it's a sign that something is wrong with an experiment. It's only a sign, so you still need to do the digging, but at least there's a very important sign that something is wrong. Secondly, in most cases, it completely invalidates the results from your experiment. And therefore, quick detection is very, very important here. And third part is that, well, we at Vista want also non-experts to run and execute experiments in a self-service manner, which means that not everyone is an expert in statistics and not everyone has full time to do the deep dive in all the drill downs that you can make. So again, quick detection and some help in analyzing what the problem is very important. Now, there are multiple methods already on the market, but there are some issues with that. So I'll share what the current solutions are, and also, again, what we did after that. Now, the first approach is very simple. You can calculate this manually, right? If you punch in some numbers in tools like the thing Lucas Vermeer here made, you will quickly learn that something is wrong with your experiment. So in this case, we observe 2 numbers, 2 samples. We have an expectation that, again, this is a 50-50 split, and this tool will tell you that there is an error. So that is one approach that each and every one of us can take, and hopefully everyone is doing that for their experiments. One better thing, also built by Lucas, is a plugin which you can download and install, and it works for tools like Google Optimize, and it will tell you inside of the tool, it just injects the information from the tool, if your experiment is actually having a problem. Now, this is already, I think, a good step forward. You don't have to go to an external tool. It's in the area where you analyze your experiments. The downside is it's quite reactive, right? So experiment owners have to go and look quite often to their tool or to their dashboards of their experiments. And then, well, it depends actually on people actually doing that behavior. So the things we build is on top of the things that are already in place within Vista. And I think that's the nice thing, because probably in your organization also similar things like this are probably already in place. So we think that you can do this as well. For one, there is a events pipeline. At Vista, we use Segment. Now this pipeline collects events where users enter an experiment. There's already data storage, Snowflake in our case. It stores events, but also metadata, and we can create views and tables with that. And of course, we have some reporting functionality. We use Looker, where we can create reports, but also compute summary statistics. So this is already in place, and this is what we've used to build the stuff that we're going to show you. And actually, we built 4 things, simple things probably. First thing is a table with the number of triggered visitors per variant. This is stored in Snowflake. Another table with the percentage of traffic allocated to each variant, also in Snowflake. Then the third thing is a dashboard showing the experiments that actually fill this SRM check. This is in Looker. And we have a dashboard showing the results per user segment. And this is also in Looker. Now, how does this look like? So the first dashboard is showing all the experiments that fill the SRM check. You can also see the number of variations and the total visitor count. And if you drill down, you can see on a couple of dimensions, you can see the drill down. In this case, you see an example of how it looks like by device. So in this case, you can clearly see that there's probably an issue with mobile. Now, the next thing that we built is that we inform experimenters proactively. And the last person that was interacting with the experiment, that person received an email, but also a Slack message informing them that there actually is an SRM error. And we link directly to the documentation explaining what SRM is, but also help them with some first steps that people can take, how to, well, further do the analysis on what is actually the issue. So this is also the not only the detection, but also the alerting side. Let me share you some results, but also some ideas, at least, what we can do next from here. Now, I think the first good thing is that several SRM issues have been identified. Automatically, people were informed and people took action, right? So I think that's a good thing, because it saves precious time from the central team, from analysts and developers, but also it really conveys the message that people need to act on this. So I think that is the first big result here that we saw. And we're not going to stop here. So we have already a couple of ideas on what to do next. Several potential areas of improvement. A paper by Linden and Malek. They introduced the concept of sequential SRM testing. So this will help you to detect issues sooner, but you can still control for type 1 errors. So this is a potential idea that we can investigate. Of course, we can add more dimensions. So we currently support browser, device type, and locale, but maybe, or we probably should add more. So this is a direction we can take. Of course, we can include some segments that we have identified that are often important for Vista, and also include that in the alerting message. And well, still we rely on people acting on the messages, right? So maybe we should think about how can we actually guard that people actually act upon the message and take action around their experiment. So that's another potential area that we need to look into. And lastly, there are many ideas in the 2 papers where we can add maybe more monitoring capabilities to this way of working. So in summary, we have automated detection of SRM checks and issues. We have implemented that in such a way that it's really proactive, alerting users about those issues. And I think we have made it possible to, prevent non-experts making decisions based on biased data. And that is really important, as you all know. Thank you very much. Questions, please reach out to one of us. But of course, we have time for questions right now. And I've put all the references to the things that I showed you in a list. So that will also be shared here. Thank you.
Awesome. Let's grab those links and also put them over in the calls channel, if you don't mind, Kevin.
Yeah, we'll do.
And Tone has a question. Let's see. It looks like the first question was already answered around the sequential sample ratio mismatch, but follow-up question, are you influencing your coin flip, or will you in the future based on potential growing sample mismatches in certain segments?
We don't do that right now. So now we've automated the detection and we alert people, but we don't influence the coin flip right now. No.
Merritt asked, with so many slices, do you see false positives pretty frequently?
Yeah, so that happens. Yes, it happens, and I think that's still the case, right? So SRM and SRM error can flag that there is an issue, but oftentimes you still need to do the deep dive and see where the actual error is. So especially in the beginning, when this concept was quite new for people at Vista, we got quite some questions back. So people were responding on, I see this error, what do I need to do? So I think at least that was our first purpose, because we got people acting upon it and notifying them that there is an issue. But it wasn't always the case that people knew exactly what to do next.
One of the things I noticed that you said was you notify them that there may be an issue, and you send them through the documentation of what they might do to go research what that issue might be and what they might do about it. Can you tell us a little bit about what's in that help text of how they might go research what may be causing the issue?
Well, when we link to the documentation, we again explain a bit about what SRM is, and we give some pointers at least to where it is, or things people can look at. But we mostly steer people to looking at the different drill downs. Mm-hmm. And one common thing is that the implementation, for example, in mobile is completely different, or is lagging, or so I think a couple of times we saw an increase, or the solution in the implementation in mobile.
Yeah, I've seen a lot of stuff with mobile, and then I've also seen a growing issue related to browser privacy and cookie issues, and the complexities inherent in that research, and the ways that the cookies are different, and how difficult that research is. And so that's why I was a little curious if you've given them any guidance on how to do that research, or when to give up and when the juice isn't worth the squeeze. Just curious if y'all had cracked that nut, or just decided when to stop or when to give up. Not yet, I guess.
No, not yet, no.
Anybody have any other questions? I see Matt typing. I have does that, Jonas, are you influenced? Does that make sense? An SRM indicates a problem in the tracking. Wouldn't that just masquerade the problem and keep the bias?
Sorry, say that again.
And if an SRM indicates a problem in the tracking, wouldn't that masquerade the problem and keep the bias? Influencing that was in relation to influencing the coin flip.
If it would masquerade, I don't understand that part.
I'm not sure I do either. That's from Jonas. Do you want to ask your question, Jonas?
Sorry, sure. Yeah, it was in relation to the comments from Ton. So Ton mentioned that maybe we could adjust the coin flip if we notice that there's an SRM to correct the SRM, but that would just masquerade the real issue, and the bias would still be there in the data, right? So that was what I was commenting about.
Yes. So our main recommendation always is to just, if we found the error, is to restart the experiment and completely start and discard the earlier results. So don't try to filter out. Although that's probably another direction we could take this, right? So especially when we only notice the issue later in the experiment life cycle. How can we still learn from the data that is gathered? But our main and probably the simplest thing is to solve what is the issue and restart the experiment.
If I can jump in, there's very few cases where I can think of where the cause of the SRM, once you know it, the solution is actually to bias the coin flip in some way. I think in a lot of cases, the cause of the SRM is missing data, and then like for example, slower tracking on a mobile device, right? You lose a very specific kind of traffic, and biasing the coin flip doesn't really solve that. So I don't think that's an area we would invest, honestly. I think that's what Jonas was saying, right? It wouldn't masquerade the problem. It wouldn't actually solve it. If the true issue was missing data, then biasing the coin flip wouldn't help. It would probably make things worse, actually.
Right. Jocelyn asks, approximately how long did it take the team to build out the automated SRM checks?
Mauricio, you know?
Was I don't know, 2-3 weeks of developer work, not too much.
How about the so that's the checks. How about the automated? Well, I guess the checks are, in fact, because you're checking, and the checks are also feeding in the recommended like actions to take, so that it's all feeding in together, right?
Well, putting it all together required some more work than development work, because we had all this documentation writing and stuff like that. But we had already this architecture that was putting like all the tracking data in our data lake. So it was a matter of creating these dashboards, creating an automated alert on top of that, and a bit of development work for this kind of Slack and email sending and stuff like that. But I would say it was definitely not expensive.
That's great. Another from the Zoom, does SRM also give a measure of the goodness of the splitting of the engine?
For all the cases of true SRM that we have seen is because of issues in the integration or implementation. We have never seen an issue really. I mean, we use Optimizely SDK for doing that splitting, and we actually have never seen issues around that. It's more issues of one of the variation was not properly configured, so it was never showing, or latency, or in a mobile screen menu was not showing for one of the variations, things like that. It's always like an issue that it's in the middle, not in the randomization itself. We have never seen an issue there.
No, I mean, you could argue that I guess the way the API is designed, it's possible to run into these issues when you implement the Optimizely SDK, but that's the sort of a function of the contract, right? So the fact that you can get the result of the coin flip without actually triggering an impression, that is one of the reasons that we get SRMs in some cases. But that's still implementation error on our side, right? We're just like, we're basically given a chainsaw, and then we cut off our own leg. We can't go like, oh yeah, the problem was with the tool. Maybe I should have a safety check. You know, just saying.
Scroll up here before I lose this question. Are you in service to your users, or are they in service to your platform? So how do you balance how your team thinks things should be done versus being too paternalistic?
We are all in service of our customers.
That's a quick answer.
That's my cop-out answer.
There you go.
And so the answer is that we service internal users, right? But so the users of our platform are internal customers. And so I think for a product manager like Kevin, that's actually an interesting proposition, because from his point of view, the user is not the most important stakeholder, because the most important stakeholder is the customers that come to our website and that buy products from us every day, right? It's the small and medium businesses that we try to help. And so I would argue that we are a little bit paternalistic, but it's in the interest of our end consumer, because that is ultimately our most important stakeholder. Hope that answers the question sufficiently. Otherwise, Matt, you have my WhatsApp. Just send me a message, you know.
Anthony asks, have you tried running the SRM check preemptively, i.e. sample random IDs from history and run assignment offline before the test starts?
I don't think we have done that before. No. Right, Mauricio?
That's a really cool idea.
Yeah. This is just idea generation for us as well.
Okay. We're all here to learn and help each other. Yeah.
So this is a really cool idea. So the challenge with this is that a lot of these SRMs are being caused by the implementation of the triggering. So we really only have historic data once the triggering is in place. But I guess as soon as we have the triggering in place, even before the test has been started, we could already start checking whether it's balanced or not. Even before if we have the code in place that actually fires the impression even before the test is running, we could already start doing this. That's cool. We could tell people your test is broken, but I haven't started it yet. Good thing.
Yeah, because
Thank you. This is awesome.
Happened before, like we have a lot of situations where, you know, the qualification happens before you start the test, right? And that's the big complication. Is like, yeah. Anyway,
we did talk about exactly the same idea at Booking.com for power calculations. So as soon as you have the triggering in place, you can already start checking whether the MDE that people put in the tool actually makes sense given the traffic that they're getting. So
yep.
We did talk about something similar, but not this exact idea. Thank you.
Matt asks, question about time experiments. I assume that the metrics calculated at the time slice day rather than the individual level, that is the metric summarized by day?
What do you mean by time slice day versus at the individual level? Do you mean as the at the visitor level or something?
Yeah. So is the data just aggregate? So it's really essentially just the data is allocated by day. So you have a conversion by day or whatever the metric is, and you just sum over the individual data, or are you trying to somehow? That's what about the sample size, the effective sample size, which is, are you using?
So I think this is one of the interesting things is that we don't know who the population is, to be honest, and this is one of the reasons why A/B testing is difficult, because your audience could be someone who's not even on your website because they've seen your prices in paid search, or they saw it on an email. Or maybe they saw it on a different part of the website where it was in the very bottom corner. So is that a visitor? Do you count that as a visitor? Or they may not even seen it because they didn't visit the product page and they weren't interested in it. So how do you capture them? So we don't take visitors into consideration. In that sense, the unit is is the day. So you are comparing performance by day or performance by time unit rather than performance by visitor. Now, that being said, you could still use time split testing for visitor, more traditional type tests. So if you were to change something in your product page experience, you could still use time split testing. I don't know why you would. You'd probably rather do an A/B test, but the same principles apply. And you can, instead of calculating, let's say, revenue as a metric, you can still use conversion rate, which is by definition orders per visitor. So
okay, so you're just calculating revenue by day.
Exactly, yeah. And this is why it's super important for us to control the days, the weekday, like the Monday, to Tuesday.
Yeah, that's fine. I just wasn't sure what the metric was.
And I think Jonas, is that your question too?
Right.
Jonas asked a question right after you, Matt, and I think it's the same question. Time experiments, if a user's tracked different units of time in different variants, how do we know where to attribute the goals? Do we attribute only if they happen inside the time unit? I think you were both asking the same question. It's basically what's the denominator if it's not.
No,
visible.
I was just asking what they're using,
Yeah.
and which is just revenue. And I think Jonas is asking about a spillover.
Oh, different units of time and different variants.
Yeah. So I think certainly Matt's question is very important for the for how we're testing list prices. And I don't want to go into it because it's a bit of a rabbit hole, but yeah, you're completely right. The spillover effect is something that is it's an equally important question. And as time split testing is still quite new, we are reliant more on anecdotal evidence of whether there's a problem with customer experience. And for many reasons, it's not come up either through our customer care or if we track how the life cycle of a purchase is, there's reasons why it isn't a problem, but we're still concerned that it could be a problem. And one thing I'm really looking forward to doing is some more like meta-analysis across many experiments to see if actually can we measure the spillover effect or get an estimate. If we change the unit size, will we start to notice the spillover effect a bit more? And then how far can we push it so that we optimize the upsides and minimize any of the potential downsides, such as spillover effects.
Awesome. Well, just like last time, this was great. Really appreciate the generosity of your sharing. Really love how you all have grown so much and brought what you've learned into the industry. Really appreciate your sharing with all of us. And thank you for posting, Kevin, all of the links into the Slack. I know you all engage in the community, and I appreciate that as well. Thank you for coming back. Thanks for all you do, and see you all next time. Thanks everybody on the TLC. We'll see you in November for our next conversation. And everybody have a great week and weekend. Bye all.